How is everyone doing today? Whew, besides sweaty. Well, while we're waiting, I'll pass around. My name's Meg Berry. Meg is fine. I am the BinarX Outreach Program Coordinator at Curtin University in the Binar Space Program. So, show of hands, has anyone heard of the Binar Space Program or Binar 1 mission? Fantastic. So, Binar 1 was the name of the CUBE satellite that Curtin staff, students, and academics designed, built, and flew on orbit in outer space in 2021. This is a display model of it. I'll talk more about it when I have my presentation up, but the BinarX program is the high school-based outreach program that we want students to design, build, test their own instruments called Payloads to go in our future Binar spacecraft and go out on orbit in outer space, and you'll get data, you'll answer science questions. I'll go all the way through it, but that's kind of the overall view of it. So basically, it's a 2-year program. It teaches critical thinking, project management, teamwork, collaboration, science communication, in addition to all the cool STEM stuff, like the electronics and the coding, microcontrollers. So Ms. Coddington's got one of these boxes. So, has anyone done any circuit design or electronics design before? It's not as daunting as you might think. I am actually a graphic designer and a project manager, but I really love tinkering around with STEM. And has anyone here done First Lego League? Yay! So it's basically robotics and coding in Python, but with Lego robots. And it's very cool. So that's my origin story, because I started as a judge and a volunteer in that space, and then I became a coach for my children's school at the elementary school level. And then when this job came up to be an outreach coordinator for BinarX, I jumped at it and I got it, and I now get to STEM Club all day, every day, and hang out with a bunch of scientists and academics and engineers who are absolutely brilliant, and just watch what they do and then come to you and get to communicate that. So I'll pass that around, please have a look. That's, it's pretty robust. Thank you, Ms. Coddington. Great. So we'll get started on the presentation. Beautiful presenter view and everything. All right, so BinarX, sending high school payloads to space. So I've already introduced myself, BinarX Outreach Program Coordinator at Curtin University. That is my past life. Graphic designer and a manufacturing sector project manager. So I've done lots of public art. I've done lots of signage at all your beautiful schools and the big statues, things like that. I love it. I like to make stuff. I like to project manage. I love to design. But I also love Lego, a whole bunch. So that is one of my 3 Explore teams from this year. And I was volunteering in that space. And I'm also an aspiring Lego master. A couple of years ago, almost got there, but couldn't leave the state for some reason. I can't remember what that was. What was going on 2 years ago? No one could go anywhere. But maybe in future. So I'm hoping to bring some Lego into this aspect. I hope you won't mind. So broadly, who are we as the Binar Space Program? Binar is the Noongar word for fireball. Now, the reason that is because we have our heritage as the Binar Space Program in the Desert Fireball Network, which is a network of autonomous cameras that we design, build, and install across Australia and across the world, in fact, that have a special algorithm in them that will pick up anomalies in the night sky. And quite often those are meteorites and meteoroids? Meteoroids. They're not meteorites till they hit the ground. Still working on that. And then we go out and we find them. And because we have a network of cameras, we can triangulate it and find these meteorites. And of course, Binar, being that it's a very small CUBE satellite, can I get a show of hands, or if someone can tell me why they think we might call our Binar a fireball, Noongar word for fireball? Any guesses why you would call a satellite a fireball? What's one of the biggest problems in space right now with all the stuff out there? Ms. Coddington?
Space junk.
Space junk. So our little satellites, when they re-enter, they burn up, and they are no more. So they turn into actual fireballs. So we launched WA's first satellite in 2021 with the Binar 1, which is what's going around now. That's just the display model with the sides off. There's all kinds of cool tech in there, but I'm not going to overload you with all the info today. And then there's Binar 234, which is what we are actually currently testing to get approval from the Japanese Space Agency to fly in August, and we're flying 3. So they look like this. They're bigger. You're welcome to come after and take a papercraft version, because they're really fun to play with when you start into these electronics kits that Ms. Coddington's got, because you can put them in there and kind of muck around with it. I like it. If it's not your thing, that's fine too. So we're launching those 3. We launched 1 in 2021. We're launching 3 more in 2024. And in probably 2026, we're going to hopefully launch at least 3 more with student payloads on board. And that'll be 5, 6, 7. And that's where we want you to design your experiments, your payloads, whatever it is you want to fly, as long as it meets the requirements of, you know, power, data, then that's what we want you to do. So there's the team. So that is our team that did BinR1 originally, and Minister Dawson, who came along. But those are all staff students. Some of them are undergraduates. Charlie there, I think that was his first year. He led the HAB launch that we just did last week, and he's only 22, and he was being interviewed by the ABC. So, you know, these are people who weren't who were high school students like yourselves very, very recently. And it's very exciting to have this pathway and this opportunity right here in Western Australia. So I'm going to show a little video. It's just a video talking about BinR1.
Kaya. My name is Professor Harleen Hain, and I have the great privilege of being the Vice Chancellor here at Curtin University. And I would like to warmly welcome all of you here today. Most particularly, I'd like to welcome the Honourable Mark McGowan, the Premier of WA, and the Honourable Roger Cook, the Minister of Science.
Can I thank you for all your work on this important project? I never expected many things when I became Premier of WA. One is I never expected I'd be dealing with a worldwide pandemic, and two, I never expected I'd be launching a spaceship. So this is something that is new to me. It's a testament to the incredible ability of the students and engineers here that you're able to do something like that.
This is pretty exciting, right? Actually, it doesn't get much more exciting than this. We are celebrating some really exciting things. One is obviously the fact that Western Australia is about to become a leader in space technology and exploration on behalf of the rest of the country. We have had 14 Australian space missions throughout the white part of Australia's history. Curtin is about to embark on 7 alone in the next 18 months from this single campus. Just really goes to the power of thinking, knowledge, wisdom, and all those things that we manage to nurture at a great campus like here at Curtin University. Okay.
The BINAR, of course, is the first of 6 or 7 BINARs that are going to go into space and perform various roles, including some that may even be going to orbit the moon, I understand. So that's an incredible thing. And to think that was all done here by a group of students and engineers at Curtin University is really quite something. So can I congratulate you on that?
It's absolutely incredible that it's right here in WA. So I'll go into the next one. Oh, no, next slide. There we are. So there is sort of an exploded view, we call it, of BinR1. So the payloads, the camera was a payload, the batteries, the magnetorquers, which I'll talk about another day, and then being put together, always with gloves. Don't want to do anything bad to it. So there it is with the sides on. So BinR1 had flat solar panels. BinR 2, 3, 4 has extra solar panels because we want more power and they're deployable. We'll talk about that later. But that is the difference of about the ones you'll fly on. So there it is launching on the Falcon 9. It was launched on May 2021, or sorry, completed in May 2021, and it was launched to the International Space Station on August 29th, 2021 on the SpaceX CRS-23 resupply mission. So Elon Musk, everyone knows who he is. He runs a lot of resupply missions up to the International Space Station, and that includes cube satellites like ours or other payloads. So that's how we got up there, and that's how we're going to get up again, just on a different rocket on a different mission. So there it is. It's pretty awesome. That's image courtesy of SpaceX, but that's the trajectory of it launching. And yeah, so it made its way up to the International Space Station. It was deployed on orbit from the International Space Station on October 6th from the Kibo, Japanese Space Association's Kibo module. So it's a little sort of spring-loaded gun that they load CubeSats. So CubeSats are always the same size and shape, so that anyone can design to that size and shape, and then use this much lower cost way of getting things. Because, you know, usually think about space missions, you think about gazillions of, well, Okay, that's an exaggeration. Billions of dollars, millions and billions of dollars. It's only the sort of purview of governments or total entire countries. But you have student groups and universities who are independently able to test technology and industry as well. So that's what's really exciting. I'll pass this one around in a moment as well. This is 2, 3, 4. So I've only got photos, but if you watch from here, and this is a bit slow because they're big photos. There we are. So that's BinR, and then there's 2 others behind it, which are from other universities or industry. I can't remember what the other missions were. But if you do Google, or if you go look in YouTube, you look for BinR1 deployment JAXA, or Japanese space industry. It's a long video, but there is a point at which you can actually see it being deployed on orbit, which is really amazing. I don't know if you recognize the planet behind. And then those are do you know what those are the solar panels of the International Space Station behind as well. So these are some of our favorite photos as a team. It's pretty humbling to see a piece of your technology floating in space above our planet. And we are actually working on a lunar mission as well at the moment to send a CubeSat to the moon. So there it is close up. And there's BinR, and it's 2 little friends, and off they go. So that's our favorite photo that you see everywhere. We use that all the time. That's just our absolute favorite. So there we go. Sorry, it's slow. We had a little bit of trouble communicating with it. We did eventually communicate with it, but it stayed on orbit for 11 days, and then its last recorded transmission was November 2021, so then we lost contact, but then after almost a year in space, we confirmed its orbit ended in October 2022 and re-entered the Earth's atmosphere and burned up. So that's what will happen with 234. So there's 234. So you can see there's a lot more tech packed into it, but where your payloads are going to go, and next week we'll talk more about what a payload is. We have a removable payload bay, as well as deployable antennas, extra solar panels to increase our power budget, because the more solar panels, the more we can charge our batteries. And then we have these lovely little payload development kits. And I know it probably might not mean too much yet, but this is what your payload will look like, plus circuits and sensors that you're going to add. You're going to design what you're going to do, decide what science question you want to answer, and you'll design a circuit which goes on, talks to this little microcontroller board that was designed by one of our interns, Lorian Marshall, who's a UWA mechanical engineer. She's amazing. She's met Carolyn Kennedy, and she's now working under Don McIntosh, who's an ex-NASA research engineer at Fugro, and that's all right here. That's all in Perth. So I'll let you pass this around. So basically we could have 4 payloads. Lorian designed these boards and quite nicely put this way to space, so we remember which way we need to point our sensors, if they're optical sensors. And then that gets hot swapped and into there. Now I'm sorry, I only have a 3D print of it because our flight models are currently being finalized to actually go into space, and they're very sensitive, so we can't bring the actual ones, but please have a pass around. You can have a look at that. So there, actually, let's go back. Oh, I don't have notes on that one. Whoops. So there is there's the SpaceX Falcon 9 rocket that we're going to go up in. This is just an image of the same rocket. And then has anyone heard of the Dragon spacecraft cargo capsule? That's where they have it. So this is the Dragon spacecraft here, which sits right on the top. Everything else is just to get it up there. And the cargo boxes go in here. So whether that's anything that the astronauts need, but that's where the BinR space payloads. So your payloads will be here on a different rocket potentially, and off into space, and then end up on orbit, just like the ones I just showed you. So that's pretty incredible. So that's what our mission is. We want you to design, build, and test your own payloads to fly on future CubeSats. I won't go over this one now. This is what a payload can be, what kind of science questions you want to answer. For me, I want to do something artistic and interpretive, because I want to make a payload and do some interesting data visualization. So it doesn't have to be, it's only limited by your imaginations, be creative. But you can also, if you just want to go and take a photo of space, or if you want to, just measure something and talk to your satellite, because it's an incredible opportunity to touch space. It can be anything you like, as long as it meets the criteria of space flight and the Cube satellite, but you don't need to worry about that today. So acknowledging the work of our 2 pilot schools, John Curtin College of the Arts and Joseph Banks Secondary College, who helped us troubleshoot any of the things to try and get our program into schools over the last 2 years. And we wrapped up at the end of last year with some space environment testing in a thermal vacuum chamber, as well as some vibration testing with our engineers. That's Dr. Robert Howie. He's fantastic. So that's what you'd be doing. And then we ran a summer holiday program, and this is something that's all open source and available. Dr. Howie took our CubeSat payloads and design them for model rockets. So 14 WA high school students from years 8 to years 11 spent 2 weeks basically doing the whole program in the 60 hours that we expect. They did it in 60 hours, but in 2 weeks, and they were there every day. I was exhausted. Hats off to your teachers that they do this all day, every day for however many weeks a year, but it was incredible. We had Dr. Newton Campbell, who's actually just about to leave for Sydney. He's also ex-NASA. He came and just chatted with the students. Hans Benz, they're the ones that are flying at the end of the year, and that's Ozzy the Lab. He's my dog. So, don't know what the MLC policy is on puppies, but just let me know. He can visit if we need to. And then also the teams analyzed their data and communicated their work, celebrated what they did. They all did their own team branding. We made custom t-shirts. They customized their rockets. It's not just engineering. There's so many aspects to a space project, and we'll talk again the next couple of weeks. We'll be talking more about that too. So, yeah, it's a whole thing. It's not just like make a thing and then it's there. It's, find out why you're doing it, what you want to do with it, what you want to answer. We launched the rockets at the end. It's pretty awesome. I don't know if you have time for a little video of how fun it is to add cameras to everything, which is something we seem to do with everything we do, and I encourage you to try the same. That's my daughter yelling. So that's a lot of fun as well. Does anyone have any questions? Did I miss anything? Did I gloss over? There's the payload. So please come up and have a look and have a look at the things we've got here. We've got the CubeSat papercraft. We've got some photos on orbit. We've got the deployable solar panels, which a little bit sharp on some edges. So just be careful. But please, don't be shy if they want to come up and have a look. These are the electronics boxes, which I really encourage you to play around with these because it's all online. This one I don't deliver, but my predecessor Rockwell Magellan, which is like the best name ever, he developed all of these activities, which are a really great way to introduce you in a really fun way to electronics, to space missions, to the context of space, and it's quite a lot of fun. It's how I got the job. I had to make my own payload. Basically, they said, you've got to design your own payload, and I did an infrared distance sensor that was sort of like a personal space alarm that went, or personal space traffic light warning. If you were too close, it was yellow. If you were really too close, it was red. And if it was a good distance away, it was green. And as someone who'd never coded or used a microcontroller, I was able to smash that out in a weekend because they didn't give me a lot of notice. So I've seen what students can do in my involvement with First LEGO League, and I'm always amazed and I'm always floored. And I know you will all excel at that if you're interested. So yeah, that's everything. So we want to introduce you to programming, building electrical circuits, design and perform your own experiments, and an introduction to space science. And next week, I may not be here in person, but you'll get the video and Ms. Coddington will present it through your classes. You can continue to explore the introduction to electronics boxes. It's fun, hard fun, but it's fun. Payload experiment concepts, we'll go over what questions we ask, why we go to space, what we observe from space. And I may or may not get in the same week to the engineering project team composition and roles. But everything we do is based on the NASA Systems Engineering Handbook. So our milestones in terms of our reviews and how we break everything down is actually based. We take our pages out of NASA's handbook, and this is actually the same process that we use when we're designing our BinarX spacecraft and BinarX spacecraft missions. So it's all very much a real thing, and we're excited to be bringing it to you. So that's it. Thank you very much.